So from the second order, again I write it here, order reaction. We have that one minus that one equal to kT. Okay, and you have to remember that half-life will happen when the A concentration is a half of initial concentration of A0. Just put it in here, meaning that this is half A, right, minus, sorry, A0, okay, that one equal to, okay, T, like that. From here, very easy, that one is equal to 2 per A0, isn't it? Yes, that one is like this, and what we get is then over there, sorry, this one should be T half, that one T half, so what we get from over there is 1 KT a half. So what is KT a half? T a half, then you can determine easily, equal to K A0. So this is for the second order reaction. Again, we also finish with the second order reaction. See, we get from the presentation file, actually already we discussed. We get straight line from the experimental setup, from the data, then we plot it between 1 per concentration of A product with the T, then we get straight line like that in the presentation, and then of course that one is second order reaction. Also half-life, we get it. Now we go for the third or bigger order reaction. But before that, just have a look in the presentation over there. This is the outline. See and just, have a look very obviously. We already discussed it. So for first order reaction, for second order reaction, only second and third column. You can see over there, sorry, from the table, just have a look. Red loss, we already seen, and integrated loss, we already see it, and then half-life, we already discussed it. So we have done for this one. Now we need to go for greater order reaction. 3, 4, even n order reaction. With the note that only simple reaction mechanism. The complicated one will be discussed in the next meeting, other meeting, not in this meeting. So let's go back to the whiteboard. We go for the greater order reaction, third and even n. If we have so sorry for this. So we have the now we have third order reaction. can be represented by A plus B plus C or other reaction. You know, this one is reactant. Becoming a product, but very important note is that the initial concentration of A0 is equal to B, initial concentration of B, same as initial concentration of C. So then integrated law of the reaction can be written by mean minus dA per dt is equal to that one of the reaction is 3. Okay? Then from this, then we can calculate it. Have a look this, that dA per A, that one is all the reaction 3 equal to K dt. Let's then we integrate this. Integration from that equation. Then this one is from 0 to t, and that one is from A0 to A. What do we have or we define from that? From this, what we will find is that one meaning half, okay, minus A square minus A0 square, and that one equal to with the same method as we already discussed earlier, you will get this. So just find it later on by yourself, exactly like this. So then what is the half-life of third order reaction? So we get KT already. Now we find half-life. The half-life will be the same as (3 per 2 K A0 square. You can do it at home by yourself because it is not quite hard. Half-life again is the time when A is equal to the half of A0. Very easy. Now the question is, what happened and how we get to the nth order reaction? By doing the same method, the same methodology, the same integration, then you will get the equation of the reaction for n order. Just have a look, because I already write on the file presentation that for n order reaction, then you have rate laws like that in the third column, integrated laws and half-life. Rate laws, integrated rate laws and half-life. So I think it's enough. So this is the summary. Because for the other order reaction, it's not that easy. I mean, I already discussed, for the reaction on the right side, the initial concentration at A is not the same as the initial concentration at B. Then the rate equation is given by on the right column. Then integration will be more complicated, and we will discuss in the next meeting. So I think this is enough for our meeting and discussion. Today we will discuss the other order reaction and the other complicated reaction in the next meeting. So thank you very much for your kind attention. Please feel free, contact me in email jaslin@ymail.com if you have any question or queries. Again, thank you very much. Good luck for you. Thank you.